So this one, this is lesson 3, and this is basic stoichiometry, and I'll be basically explaining the mole map. I really suggest having this written down or like memorized. I'd write it down about like 15 times. It trains your body just to like memorize it whenever you write it. But so this is the problem that we're starting with. 2 hydrogen dihydrogen, 2 dioxide, and 2 water molecules. So we're gonna just say, but the central thing is this is more so the more important thing. So this mole is grams, liters, I do volume, mass in grams. This is Avogadro's number, and this is I don't know if I can see this, but basically this is the moles of your like mole A. Then up top is Avogadro's number, outside is volume, the bottom is mass, and then this is the conversion from the top. So I guess I'll just kind of walk through how to solve it in each way. So if you started off with 3 moles of H2 and you wanted to go to liters, then at STP, basically when you're doing this, you're canceling out and you're moving to liters. So if I said I want you to go to liters of H2, you just do this, 1 mole of H2, because you're always trying to get rid of what you started with. Whatever you start with, you're trying to cross out moles and moles, and we're trying to move to liters. Liters is always going to be always going to be 22.4 liters. Okay? So when you multiply this together, you should get 66. So you should get 67.2 liters. All we did was multiply across the top, right? If I wanted you to go from moles to the grams of H2, so we're going to put always 1 mole of H2. Always get rid of it on the bottom. You just want to cancel that out. When you go to grams, you're going to look in your RDC. On the RDC, you're going to look at the number right below the letters that is going to be the atomic mass. Ironically, the atomic mass is always going to be equal to your moles. Or not, yeah. It'll be just the unit of moles. So H2, don't forget, if you have 2 of them here, you have to do 2 H2s. So H is equal to 1.008, but you have 2 of them, so you're going to add another 2.062, right? So on this side, it's going to be 2.062 grams of H2. Well, you can see that I have about 6 2.016 grams of H2. And then when you multiply that together, you get 6.048. Should be. And that would be your answer. The picket fence will last as long as you need to send it. But then if I was to do avocado's number, it's always 6.022 times 10 to the 23rd, positive 23rd every single time. 6.022 times 10 to the 23rd. It's in your REC. It's right here. It's going to be the same thing every single time, like clockwork. You're going to multiply those together, cross out the moles out the ways, and that'll be your answer. I'm going to just do that in my head. I'll show you guys a harder one to do. Alright, so this one, when you're going from one mole to a different mole, saying if I wanted to go from H2 and I wanted you to end up at H2O, or H2 and I want you to go to O2, you're going to look at the coefficients in front of them. So if I said I want you to go from H2 to O2, right? The conversion ratio is going to be 2 moles of H2, because the coefficient 2, it gives you that, and then you're going to 1 mole of O2. So then you'd be having 3/2 mole of O2, right? Because you just multiply that across. But anytime you're going from one element to the next element, look at the coefficient in front, and that'll tell you what the conversion ratio is. So now I'll walk you through more so of a harder problem to make it easier, or a longer problem, I should say. Let's go from you go to your back, your skills practice. We're going to do this one. I'm going to just give you a theoretical problem. So 25, or actually, let's say I give you we're going to do 50 moles of O2, and I want you to end in liters. We're gonna end in grams. Actually, yeah, we'll end in grams of. No, we'll end in grams of H2O. Grams of H2O. So we start with 50 moles of oxygen. So boom, boom. So we're already at moles, so we can go straight to the other moles. So 25 moles of O2 is the same as that 18 moles H2O. And then you're going to take, so we crossed out moles of H2O, or moles of O2. We got rid of them. That's the goal, right? Now we're gonna we want the grams, so we want how much is in each mole, right? So we're gonna put 1 mole of H2O, and now we have to calculate this. So O is equal to 16. We're adding an H, adding another H, which is equal to 1.008, 1.008, so we get 18.016. Alright. So that on top is going to be 18.016 grams of H2O. So that's what it looks like. And then we can cross out moles of H2O. Cross out moles of H2O. So all we're going to be left is grams of H2O. And then you'll multiply across. So it'll be 5 times 18 times 18.016. And you'll divide it all by 25. And that'll be your answer. And always check sig figs when you're going through conversions and like conversion factors. Whatever like you're converting by, it does not matter. Always do conversion factors based off of what you start with, right? So here's a cool little trick that I've learned. If I have a number, this is kind of sig figs if you don't know your sig figs. So if I have 5,000, right, and I have no decimal. If you have no decimal, you're gonna always shoot an arrow from the right. And so the arrow is gonna go through the loop, through the loop, through the loop, bang, hits everything past here is the amount of sig figs. So we only have 1 sig fig. If I had 300, or yeah, let's say 556 or 505,600 or something. No decimal, arrows coming from the right. So we go through 2 loops, boom, we hit everything past here counts. So 1, 2, 3, 4, all of these count, 4, 6. But if we have a decimal, decimal, you're not allowed to shoot from this side. So we gotta shoot from this side. And as soon as it hits, everything past here counts. So 1, 2, 3, 4, 5, 6. Same thing with 0.00362, right? So we got a decimal over here. So since we got a decimal, we gotta come from the left side. So that we go through, and hit, boom. Everything to the right is now a sig fig. So 4 sig figs. I hope that helps. So yeah.